All right, everybody, we are going to get started with chapter 1 of Algebra 2, and that begins with section 1.1. And the first thing that we are going to talk about is different kinds of numbers. Okay, so everything that we've talked about so far is under the category of real numbers. Okay, and then within that, real numbers are split up into two categories. We have rational numbers and irrational numbers. Rational numbers and irrational numbers. So, what are irrational numbers? Irrational numbers are things like pi, or the square root of 5, or 5 square roots of 3. Basically, anything that has an infinite decimal, an infinite non-repeating decimal. Infinite non-repeating decimal. And anything that isn't irrational number is a rational number. Okay? Shoot, I should grab a calculator, but I'll be right back. Okay, so let's take a look at pi. Pi is 3.14159, and it goes on forever and ever and ever. Square root of 5, 2.236, goes on forever and ever and ever. 5 times the square root of 3, 8.66, goes on forever and ever and ever. Another one we could add to this list is the number e, which is a number we're going to talk about later in the year. Okay, so those are irrational numbers. Now, within rational numbers, we have, so I'm going to make this a big box here. Within rational numbers, we have things like integers, okay, and within integers, we have whole numbers. So, you guys all know what a whole number is. Whole numbers are just like what it is, whole numbers, 2, 5, 7, 11, whatever, okay? 0. As soon as you want to get negative, though, that's where we have integers, okay? So integers are positive and negative whole numbers. Rational numbers are fractions or decimals. So negatives here. Fractions and decimals. So 2/3, 1/2, 0.5, 7/3. So you might be asking, well, wait a second. If I do 2 divided by 3, I get an infinite decimal. This is 0.6 repeating forever and ever and ever. So why is it not irrational? That is because it has a pattern. It repeats. Okay, same thing if I do 1/7. 1/7 actually repeats itself. It goes 1, 4, 2, 8, 5, 7, and it starts over again. 1, 4, 2, 8, 5, 7, and it keeps going. So let's try classifying some of these numbers. Example 1. Let's say we have 0.6 repeating, square root of 2, 0, -5/2, and 0.5129. All right, so first, we're going to order from least to greatest. Least to greatest. So I look at all these. Well, that's the only negative one. So that's going to go first. Then I'm going to have 0. Now, 0.5 is smaller than 0.6, but what's the square root of 2? The square root of 2 is 1.4, so that's actually going to be the biggest one. 0.6 repeating, and then square root of 2 is the biggest. Now, we're going to classify all of these, which means we're going to look at this chart and figure out where these numbers go. Now, these are all real numbers. They all fall in the category of being real numbers, okay? Square root of 2 is irrational. It is a decimal that goes on forever and ever without a pattern. 0.6 repeating, that is a rational number. That is a rational number because even though it's an infinite decimal, it has a pattern and it continues. This one is also rational because it is not an infinite decimal. All right, 0 is a whole number. And lastly, we have a fraction here, so that is rational as well. All right, so you need to know the difference between a whole number, an integer, a rational number, and an irrational number, and know that they all fit in the category of real numbers. Okay. Example 2. We are going to talk about inequalities versus interval notation. Okay, so let's say, for example, I have this. That reads x is less than 3. Now, if I were to graph this on a number line, this is something you would have done last year in Algebra 1. We will put an open circle and we would shade to the left because x is less than 3, but it does not include 3. X is less than 3, but it does not include 3. So remember, an open circle, and I'm going to write it over here, open circle means that it does not include. Versus a closed circle is colored in, and that means it does include. Now, let's consider a different example. Let's say I have x is greater than or equal to 1. Here's 0, here's 1. I'm going to put a closed circle here and shade to the right. All right, now we are going to talk about interval notation. Interval notation. When it does not include a number, you use parentheses. And when it does include the number, you're going to use the brackets, the squared brackets. So if you look at what's shaded, I'm going to keep going and going and going forever to the left to negative infinity. And then I'm going to go all the way up till I get to 3. Okay, so to write this in interval notation, I would say we go from negative infinity to 3. Negative infinity to 3. Let's try this next one. If I look at this number line, I start at 1 and I'm going to positive infinity. So to write this in interval notation, we would have the closed bracket at 1 and then a comma and then up to infinity. Let's try another example. Let's say I have 4 is less than or equal to x is less than or equal to 6. That means x is between 4 and 6. If I were to graph that on a number line, here's 4, 5, 6. I would have an open circle at 6, a closed circle at 4, and I would shade between. If we write that in interval notation, I'm including 4, but not including 6. All right, that is it for lesson 1. Give those homework problems a try, and we will definitely do more practice when you come back to school.